Hi class, another typical question that you're going to see within lines is that they're going to give you two coordinate points, and then the main idea is that they're going to want us to use, well, some of the equations given in here. And the only one that we rarely use is the standard form. Remember that for the standard form, well, technically A, B, and C are integers, with A being greater than 0. So technically, once you rewrite it in that form, you have to make sure that you get rid of all the fractions, and then you express A as positive. Okay, so let's take a look at this one. And the easiest portion would be, let the first coordinate point be the x's, x's 1s, y 1s. Second point be x2, y2. So I'm just going to say, let x1 comma y1 be 3 comma 2, then x2 comma y2, this is 1/2 comma 1/3. So the actual slope that contains both coordinate points of the line that goes through them, it's going to be m is equal to y2 minus y1 divided by x2 minus x1. So your y2 is technically 1/3 minus the values of 2 over your x2 is 1/2 minus the values of 3. And what I'm going to do here is, technically, let me cancel the fractions. Your LCD is equal to 6. So multiply the top times 6, multiply the bottom times 6, and we're going to basically obtain the following. And keep in mind that you're multiplying every one of the terms. So as you multiply the first value, 6 divided by 3 is equal to 2, minus 12 over 6 divided by 2 is equal to 3, minus 18. So we're looking at negative 10 over negative 15, which is equal to 10/15. And actually that's it. No, because we could divide by 5. So I'm just going to divide by 5, and we end up with, so 2/3. That would be the slope of the line that contains both of those coordinate points. Let me just rewrite it as the values of m is equal to 2/3. Okay, the next portion of this problem is they want us to use point slope form. Now for point slope form, the equation technically has the y1s, but you could have just changed those for x2, y2. It's not unique, so I'll just continue using what I used on technically part 1. So we'll be using x1 comma y1, which happens to be the 3 comma 2, and then the slope, well, we found that to be 2/3. So the point slope form, it's going to have the following format: y minus y1 is equal to m times x minus x1. So for our problem, we're just going to have y minus 2 is equal to 2/3 times x minus 3. And that is our solution. We don't actually do anything else. We would only simplify a couple of double negatives if we do end up with double negatives, but that would be our solution. Let me fix that to this is our solution. And then for part C, so they want it in slope intercept form. The easiest steps to do is to basically just use your previous solution. In this case, let me rewrite it as use y minus 2 is equal to 2/3 x minus 3, and then distribute out the actual 2/3. So we're going to end up with y minus 2 is equal to 2/3 of x minus 2, because we end up with the 3's canceling, and then, well, let me just add the 2's. So our final solution for this one, it's going to be 2/3 of x. And that's actually it. Now remember that, well, slope-intercept form means y is equal to mx plus b. So if this were to show up on the software, like the Pearson software that I talked about, you may end up with 2/3 of x plus 0. The software may actually want you to input the 0 just because it's technically needed. Okay, so let's take a look at the last one. And they want the equation in standard form. So in this case, they want it at ax plus by equaling c. And it's just much easier to actually use the previous solution. This is 2/3 of x. And what I'm going to do is I'm just going to be subtracting the 2/3 of x. So minus 2/3 of x. And that's going to give us a negative 2/3 of x plus the values of y equaling 0. Now here's the problem with standard form. We have to have a, b, and c to be integers, and technically a has to be positive. So in order to accomplish this, let me multiply by -3, and technically both sides by -3. And this is going to give us, well, x minus 3y, and this is equal to 0. Now keep in mind that all we're doing is just rewriting the same equation in different format. But this is our solution for this problem. And I just noticed that I'm missing the 2 here. That's the resulting, the 2 that's above it. So it's actually this one. So I was missing that 2, which is technically positive because that negative was absorbed by the actual y's and technically the 0. Now, once again, I just wanted to show you guys that, well, part B, C, and D is just different ways of expressing the same equation, and I just need you to recognize that it's the same equations. Let me show you in decimals. The coordinate points that were actually given are 3, 2, and 1/2 and 1/3, which you can see here. And our first solution was the point slope form, so that's what we obtained technically here, with y minus 2 is equal to 2/3 times x minus 3. That's the actual line that contains those 2 coordinate points. Then from there we went to slope-intercept form, which we ended up with y is equal to 2x over 3. That would be the second one, and as you can see, it's just going to be actually, let me change the color. There we go. Okay. Then it's just a different way of expressing the same line. We're just overwriting it. And then the last one with slope-intercept form, we ended up with 2x minus 3y is equal to 0. And you can see here when I activate the line that it's technically the same line. Different ways of rewriting the same solution. Once again, the main idea is that you review these and they'll show up in later sections or later classes. That's actually it for example 2.